Okay, salam alaikum guys. Today I'm gonna be talking about impulse. And impulse, we use the letter I in physics, which is also used for current. I apologize about that. So impulse, I, is just the change in momentum, it's delta P. So it is P final minus P initial. Okay, so that is the impulse. When I was a student, I was really confused about teachers talking about conservation of momentum. So if momentum is conserved, that means Pi equals Pf in a collision. And if Pi equals Pf in a collision, it means Pf minus Pi equals 0. And that would be delta P, and that would be the impulse. And I was like, impulse is 0. Delta P should be 0. Why are they talking about delta P anyway? So, and now, okay, so that was when I was student. Now that I'm a teacher, I can appreciate the struggles of my students. So delta P, here I have, let's say, a block 1. And here I have block 2. When I talk about the system, this is of crucial importance. The system consisting of block 1 plus block 2, if I'm talking about the system block 1 plus block 2, for this system, delta P should be 0, meaning in a collision between these two blocks, in this system that consists of block 1 and block 2, delta P is 0, or P initial equals P final. However, if we talk only about block 1 or only about block 2, block 1 is gonna feed a force that we're gonna calculate, and then the impulse of that force is going to be delta P, but this delta P is just on block 1. And also block 2 will have an impulse, that's the delta P on block 2. But this impulse here, or this delta P here, would have, let's say, a value of plus 5 kilogram meter per second. This one will have a value of minus 5 kilogram meters per second, because of Newton's third law of motion, action-reaction. Block 2 will be acting on block 1 by this force. So this force is from 2 on 1. And block 1 will be acting on block 2 with a force of the same magnitude, but it is in opposite direction. So this is what's happening here. These two forces, they are equal in magnitude, but they are opposite in direction, and that's why we call them an action-reaction pair. So on block 1, you have a force. On block 2, you have a force. But if you consider the system consisting of block 1 plus block 2, this force here is going to the left, this force here is going to the right. The sum of these two forces is going to give you 0, and that's why the momentum is conserved, and that's why delta P equals 0 for the system consisting of block 1 and block 2. Okay, let me take an example, because examples are always nice to illustrate concepts. So, and this example, I'm taking it from a previous IB exam. So there was a train here, a 500 kilogram train coming at a speed to the right 6 meters per second, then colliding with a 700 kilogram train that was at rest, V equals 0. Then this is before the collision. Then after the collision, what happens is the following. The 500 kilograms block recoils and goes in the other direction with a speed of 1 meters per second, or a velocity of -1 meter per second. Direction to the right is usually taken positive. And then the 700 kilogram train goes in the other direction at the speed of 5 meters per second. Okay, so let's calculate, let's calculate the momentum of the system before collision. And this after collision, just trying to stay a little bit consistent after collision. So here, how do we calculate momentum? Remember, momentum P equals mv, okay? P equals mv. So P total here is going to be 500 times 6 plus 700 times 0. And so this guy is just 0. 500 times 6, this is 3,000 kilogram meter second minus 1. So this is P initial before the collision. Now P final after the collision of the system, you see that I added here, there's a plus. P final of the collision, I've got here 500 times -1 plus 700 times 5. And then, so it's gonna give me -500 plus 3,500. So -500 plus 3,500. So I'm gonna have a PF of 3,500 kilogram meter per second. You see? Okay, oops, sorry. So -500 plus 3,500. So I'm gonna have 3,000, okay? 3,000 kilogram meters per second. And so you see that the P final of the system consisting of the two trains is the same as the P initial of the system consisting of the two trains, 3,000 kilogram meters per second. Now, I want you to pause the video and think about delta P for the 500 kilograms. Find the value of delta P, or the impulse, on the first block, the 500 kilograms. Also, the impulse on the train, the 700 kilograms. Let's see if you will find, so here P initial equals P final. So delta P for the system is what? Is P final, which is 3,000 minus P initial, which is 3,000, and it is a 0. But this is for the system consisting of the two blocks. Now let's pause the video for a moment, and then I want you to calculate the impulse for block 1 and then the impulse for block 2. Okay, so 6 meters per second, 500 kilograms, 700 kilograms, 0 meters per second, or usually they will tell you that it was at rest. Then 500 kilograms minus 1 meter per second, and 700 kilograms, 5 meters per second. Okay, so let's consider the 500 kilograms here. The block 1 is the 500 kilogram. So let's calculate for block 1, let's calculate the impulse, or delta P, okay, on block 1. So it's going to be P final on block 1, P final on block 1 minus P initial on block 1. So what is that? That is going to be, what is P final? Is just the mass times the V. So 500 times -1. That's my P final for block 1. minus what is the P initial is 500 times 6. So what is this? This is minus 500 minus 3000. So the impulse on block 1 is going to be minus 3,500 kilogram meter per second. You see this negative here? It's because this block is going to be experiencing a force to the left, hence the negative sign here. So can you guess the impulse or the delta P here? Can you guess the impulse on the 700 kilograms or on block 2? Okay, so this is block 1, here block 2. So it's just going to be the final, which is 700 times 5 minus the initial, which is 700 times 0. And it is what? It is 3,500 kilogram meter per second. Notice the difference in sign here. Here I have a negative sign. It means the force that block 1 is going to be experiencing is going to the left. Here I have a plus, you see, plus. I don't have a negative sign, so I have a plus sign. So it means that the 700 kilogram is going to be experiencing a force to the right. Okay, so that's it. Let's continue. Now we have defined impulse, and I showed you that in collisions, the total momentum of the system is conserved, but however, the momentum for each block is we're going to have a delta P or an impulse, and that delta P or impulse is going to help us calculate the average force on each block, and that average force is just delta P over delta T, or impulse over delta T. So we calculated that on block 1. What was the impulse on block 1? The impulse on block 1 was negative 3,500 kilogram meter per second. And on block 2, the impulse was plus 3,500 kilogram meters per second. Now, what else do we need to calculate this average force? We need a delta T. We need a time, a delta T. So let's decide that the collision took, it's just an example. Let's say that delta T equals 5 seconds. And then we ask you, calculate the average force that block 1 is experiencing. So F average on block 1 is going to be the delta P. I'm going to replace it by negative 3,500, and then I'm going to divide by 5. That is going to give me 35 over 5 is 7 minus 700. You guessed it, it's a force, so it's Newton. So minus 700 Newton, so it is to that, in that direction. Then if we want to calculate the average force on block 2, then it's going to be, this is block 1 and this is block 2. It's going to be plus 3,500 over 5, and it is going to be plus 700 Newton. See how beautiful this is? Action, reaction, minus 700 plus 700. So if you consider the system of the two blocks, those are going to be internal forces, and they are going to cancel each other out. Okay. So also I want to finish by stressing the fact that F average is inversely proportional to the time delta T. So if you want the force of impact to be small, you need to make this delta T very big, and that's the purpose of airbags. You know, in a collision, in a car collision, you know, the fact that you have an airbag there, what that airbag is doing actually is to increase the time, the delta T, and therefore to decrease the force that the driver will feel. And that's how physics is used. Physics is everywhere. Okay, thank you so much, and I'll see you in another video, inshallah.